Welcome to the heart of Jolly Olde England, where today we'll be visiting the Royal Observatory at Greenwich. This is one of the most exciting episodes of KPO's European Astronomy Tour, where we'll be interviewing the curator of the museum and learn about the history of the ROG. Come with me to continue Kissimmee Park Observatory's European Astronomy Tour. Hey, hello, hi, and welcome to episode 5 of KPO's European Astronomy Tour. I'm Dave Hearn, and I'll be your host. On this week's episode, I have a really interesting story to tell you. This morning, I'm standing just down the hill from one of the greatest and most famous observatories in the world, the Royal Greenwich Observatory, just outside of London, England. The ROG is the birthplace of modern timekeeping standards, and it's situated right on the prime meridian longitude line of the Earth. The term Greenwich Mean Time, or GMT, was established here and provides the basis of all time zones around the globe. So we have an exciting time planned for today. We're going to go up into the observatory and check out all the interesting landmarks on the property. We're going to get a tour of the Thomson 28-inch Great Equatorial Refractor Telescope and have a chat with Dr. Louise Devoy, the curator of the RGO Museum here. I'm so excited. So let's head on up, shall we? Well, here we are on the grounds of the Royal Observatory Greenwich, and I'm super excited to have a very special guest today. We're being joined by Dr. Louise Devoy, curator of the Royal Observatory Greenwich. Dr. Devoy received her master's in astrophysics from the University of Leicester. She then began her postgrad studies in the history of science at the Imperial College London, and then embarked on her PhD in the history of science in museums in collaboration with the Science Museum of London. After serving at the Smithsonian in the US and the National Space Center here in the UK, she landed here to become the museum curator, an amazing position to be sure. I'd like to welcome Dr. Louise Devoy to our show today.
Thank you, David. Thank you for inviting me.
So I've been really looking forward to this interview and this amazing historical observatory. Tell us about your role here at the observatory.
So I'm part of a small team of curators here, and we all have different collections responsibilities. So my responsibility is for our historic scientific and astronomical instruments, both those that were used here on site when the observatory was a functioning observatory, but also we have an amazing collection of astrolabes and sundials, so we can really tell that wider story of timekeeping using the sun, moon and stars. Okay,
can you tell our viewers about what those different instruments are, astrolabes? And
yes, so an astrolabe is essentially a flat disc with a rotating section on the top, and it partially mimics the movement of the stars across the sky, and you can use it a bit like a calculator or computer. You can determine the time at which the stars rise and set, you can tell the time using the sun and the stars, so a very versatile instrument.
Okay, and a transit?
Transit instruments here as well, yes. So we have those in the Meridian building as well.
Okay.
Yeah.
Very, very good. So the ROG has had a very rich history here, but I know it's been in different places as well, down at Herstmonceux and Cambridge, and can you tell us a little bit of that history?
Yeah, absolutely. So like every organisation, the observatory has had to adapt and change in response to new priorities and new technologies over the course of its 300-year history. And certainly when it was founded in 1675, the emphasis was very much on mapping the stars to help navigation at sea. This was really crucial at a time when new trade routes were opening up between Europe and the Americas, Asia, Africa. So navigation at sea became crucial, both politically and financially. And the observatory had a really key role in that. And that formed the bedrock of our work for the sort of first 200 years or so. And then in the 19th century, the work here started to change in response to changes in society. You now had railways, the telegraph networks, the post office, communication system. So all of these new sectors needed accurate timekeeping. So the observatory became a hub for distributing accurate time signals, starting with the time ball that you can see on the roof of Flamsteed House. So that was installed in 1833. and it's there as a visual time signal for mariners waiting just down the hill on the river. So they would look up the hill just before 1 o'clock, the ball would rise to the top and then drop precisely at 1 p.m. And you can use that to check your chronometer before you go out to sea.
Fantastic.
Really simple idea, but very effective.
Right.
And then in the 1850s, new technology came in. So we now had an electric clock, the Shepherd master clock, that would send electric impulses to a series of slave dials at various railway stations, and also to our. Did you see the large clock by the main entrance?
I did when I came in, yes.
Yeah. So that was originally linked to the master clock, and that was the first clock to show Greenwich Mean Time, GMT, for the public. So a very important role that continued right through into the 20th century with radio signals and obviously the very famous 6 pips that you can hear on the BBC.
And then the move down to Hurstmonceau and then to Cambridge.
Yes, absolutely. So, I mean, even in the late 19th century, the astronomers here were struggling with increasing smog and light pollution, and things weren't helped when we had the new power station installed almost on the Meridian, down on the banks of the River Thames. So you've got this huge coal-fired power station belching out smoke and dirt.
Oh dear.
Not a great choice.
No.
And also lots of sulfur dioxide that used to tarnish the mirrors and things like that. So a really unwelcome neighbour, if you like.
And they were not overcoated mirrors like we have nowadays. So,
exactly. So really, really vulnerable to any sort of change in the atmosphere. And so, I mean, things sort of maintained a steady course for a few years, but by the Second World War, things were not looking good. And after the war, in the late 1940s, it was decided that a more rural location would be ideal. So a search was put out, and then they decided upon Hurstmonceau down in Sussex, so about 50 to 70 miles south of here.
We're heading there tomorrow.
Oh, brilliant. Great. So as you'll see, it's a castle surrounded by lots of land, and it was ideal for setting up all these new telescopes and new domes. Some of the instruments were transferred down there. As you can imagine, a very laborious process.
Yes, they're huge.
It's not something you can move overnight, and it took a good 10 years to make that transition from Greenwich, which by then had become part of the National Maritime Museum as a historic site, while the functioning observatory had moved down to Sussex. And then in the 60s and 70s, astronomy itself was changing to bigger, more collaborative international projects. So you now have observatories in Australia, in the Canary Islands, with much better seeing conditions, much bigger, grander instruments that no one country can really sustain on their own. So then by the late 1980s, Hurstmonceau itself was starting to become less useful. And so they moved to Cambridge, where it's more of an administrative centre, really. Not much to see.
We're always fighting light pollution and different kinds of pollution. They had the same problem down there.
Exactly, air quality, light, and also going back to the power station here, you've got the vibrations from the turbines, and there was a lot of magnetic and meteorological research being done here as well. And as the railway lines were becoming electrified, that was really disturbing the very sensitive magnetic instruments. So they were all transferred down to Surrey, but again, they were encroached, and they had to move down to Devon.
Okay. Great. Well, this is a beautiful location up here on the hill. Can you tell us a little bit about what the different buildings and facilities are here? You mentioned the time bulb.
Sure, absolutely. So if you'd been here, say, 300 or 400 years ago, this would have been within a royal hunting ground within the park, and there were the remains of an old hunting lodge up here on the hill. Great views across the river, and this would have been quite a rural location. You wouldn't have been in London as such. So this site was chosen for the new observatory, designed by Christopher Wren, and he came up with this very elegant red brick building. So you have the octagon room on the top, or the Great Star Chamber, as it was known then, with a series of dwelling rooms underneath. So that was where John Flamsteed, the first Astronomer Royal, his wife and assistants and servants all lived and worked. Then you have sort of various extensions over time, because it was actually a condition of the job that the Astronomer Royal had to live here. So you can imagine you've got your family, you've got your servants, a whole network of people living here.
Support.
Exactly. And then this building here behind us, this is what we call the Meridian Observatory. So unfortunately, the octagon room, beautiful as it is, it's not ideal for making those transit and meridian measurements because it's slightly skewed. So Flamsteed set up another building here for observations, and then his successors, Halley and Bradley, develop their own meridians. And this building here sort of gradually extended further eastwards as each astronomer royal tried to create their own meridian. You always want to make your own stamp and do your own thing.
Right.
And then it culminates at the end with the Airy transit circle, which later went on then to define the prime meridian in 1884.
Fantastic. So with just such a fantastic facility, I bet you get a lot of visitors every year. What are the numbers?
It's about 600,000.
Wow.
Sometimes in the peak we can get over 3,000 visitors a day, which is a real challenge when you think that this site was designed for only a handful of people.
Sure.
It was very much a working observatory, but it's a really unique place, and you can really see how the site has changed and how astronomy has changed from positional astronomy to these huge equatorial telescopes.
Right.
And then the building on the south of the complex was very much about photography, astrophotography, but also the supporting requirements of having a dark room and somewhere to store the glass plates and so on. So a real industry here.
Yeah. Did they grind mirrors and do optics here, or?
No, that was always bought in.
Okay.
And there's usually...
That's a big facility.
Yeah, and there have been very strong links between the astronomers here and the London community of scientific instrument makers. We know that, say, Neville Maskelyne worked with Thomas Earnshaw and Ramsden and so on. They were always trying out new ideas, trying out new telescopes and things. So,
Right. So with all these people coming, what kind of astronomy outreach do you do for the public? Do you do like observing nights or things like that?
We do. We have a fantastic program. So in addition to our sort of general admission, we also do activities for school groups, which is obviously tailored for the curriculum. We do family activity days. On nice days, maybe not today, we have solar observing here sometimes. We also do special events. So, for example, the transit of Mercury back in May.
Oh, right.
We have a fantastic team of volunteer amateur astronomers who bring in their telescopes, put on filters and so on, projectors, so we can do lots of solar work. We also take part in the Open London House event in September, where we open up parts that aren't normally open to the public for special groups, for tours. So that's a really great event. So there's always something going on.
Yeah, and the big astrophotography exposition.
Absolutely, that's a real star in our show. And I really love that because it really resonates with the history of the site, all the innovative work that was done here for astrophotography. To think now that people can achieve very similar results globally using handheld technology that you can just buy off the shelf. It's just phenomenal.
Okay, well, I hope all your visitors are impressed as I am. I would love to see some more of this place, like get into the Great Equatorial Dome and see it's a 28-inch refractor.
Yes, 28-inch refractor.
Okay,
Yeah,
well, I'd love to see that. Can we go see them?
Yes.
Okay, let's go see it. Well, we've entered the Great Equatorial Dome with its iconic onion shape, and behind us is the 28-inch Great Equatorial Refractor. What an incredible instrument. Can you tell us something about it?
Sure. So the mount that you can see was actually part of an earlier telescope that was here in the 1850s, and this is a classic English-style equatorial mount. So it's aligned with the Earth's axis and it moves parallel to the equator. The telescope itself is originally from the 1880s. It took several years to make and was finally installed in October 1893. And it was made by Howard Grubb of Dublin. You may have seen some other telescopes from the same very well-known company at the time. And this is partly in response to the new technologies of spectroscopy and photography emerging in the late 19th century. And it was felt that Greenwich was actually running a bit behind compared to other observatories in Europe and in the States. So William Christie, the 8th Astronomer Royal, managed to get the funding. And it consists of a 28-inch diameter lens, actually sort of two lenses, a crown and a flint. And the idea was that you could flip these for photography. But as you can imagine, such a huge, heavy lens, it's about 70 pounds in weight, not very versatile or very useful for that. So this telescope pretty much became dedicated to double star observations, the idea being that you can determine the mass of the component stars from doing these observations. And the photography was actually done using other telescopes that were installed elsewhere on the site.
Yeah, yeah. And there used to be, was it a 13 MERS finder scope or something on this one, or?
Yes, so before this, there used to be a 12.8-inch Mertz refractor telescope. Yes, so that was originally here, and you would have had a sort of drum-shaped dome.
Right.
And then when this telescope was installed on the same mount, they found that it was slightly too long, and so that's why they've gone for this sort of curvy onion-shaped dome instead.
Right, right. What's the mass? This is massive. Do you have any idea?
It's several tons. I think it's about 8 tons or so. It's
Wow.
really, it's supported by a huge pier that goes all the way through the building. And originally it would have been powered by a water-powered clockwork drive to keep it in sync with the stars.
Right.
Obviously ideal for long exposures for photography.
So this is the same type of deals like the Hooker telescope at Palomar, right? I mean, there's the base and then the tower. And
Yeah, with the north pier and then the, sort of the axis. Yeah.
That's very neat. Beautiful. Okay, so in all the transition back and forth to Hersman-Su and such, was this scope moved?
Yes, actually, even in September 1939, with the outbreak of World War II, a very wise decision was made to remove that precious glass lens.
Right.
It was stored in some caves down in Kent, and then after the war, it was decided not to reinstall it here, but just go straight to Hersman-Su. And then whilst it was there, it was still used for the double star work right up until 1970, and then it was decided to bring this back as a historic museum piece, and the whole transfer was actually photographed and filmed by Patrick Moore, and he did a whole special episode of The Sky at Night all about the reinstallation of this. And we still use it today. We have our public program Evening with the Stars, so during the winter months you can actually come and have a look.
And now that's astronomy outreach. You bring somebody in to look through something like this. Is there actually, there's an eyepiece right there, huh?
Yes.
Okay,
yes.
Wow. Yeah. Fantastic. Well, that's really all I had for you. Thank you so much for joining us. Where can our viewers find out more about you and the observatory?
So if you look at our website, rmg.co.uk, there'll be all the information about the observatory and our planetarium shows as well.
Okay, well, fantastic. Thank you so much for having us.
Great.
Ladies and gentlemen, Dr. Louise Devoy.
Thanks, David.
Fantastic. We'll make sure to have all those links to that in our show notes for the episode on our website. Well, it's been an absolutely thrilling visit, and I've really enjoyed speaking with Dr. Devoy. So let's head out to the Prime Meridian line and straddle the eastern and western hemisphere of the Earth right after this break. The Royal Observatory in Greenwich is the home of Greenwich Mean Time, otherwise spoken of as GMT. The Royal Observatory is also home of the prime meridian line of the world, and there it is. It's the line where east meets west, 0 degrees, 0 minutes, and 0 seconds of longitude. So what is a meridian? It's a north-south line that was selected as the zero reference line for astronomical observations. By using this common point of reference over time and capturing lots of data based on that same reference, it made it possible to build up an accurate map of the sky from multiple points around the Earth. The zero longitude reference also provides a basis for map making. Every place on Earth has been measured in terms of its distance east or west from this line. The line itself divides eastern and western hemispheres of the Earth, just as the equator divides the northern and southern hemispheres. So the other huge standard that's been defined here at Greenwich is the notion of the zero time zone, or Greenwich Mean Time. As we travel west from here to the United States, we cross 5 different time zones. In each different time zone referenced locally, the sun appears at the same position in the sky at the same local time. But to make that happen, clocks have to be set 1 hour difference in each time zone. Astronomical events need a common frame of reference to allow people in different time zones to know when the event will actually occur. So Greenwich Mean Time is used to set that standard. This concept was established in the year 1675. So in our conversation with Dr. Devoy, she mentioned the relocation of some of the telescopes originally housed here. They were moved to Hersman-Su Castle down in southern England. That's our next stop, where we'll check out the different observatories and telescopes that now live in that equally historic location. Stay tuned for more great stuff coming up right after this. So here we are on location at the Observatory Science Centre in Hurstmonceux, England. This is near the southern coast of England in East Sussex and has been more recently the home of the Royal Observatory. As we learned from our discussion with Dr. Devoy yesterday, by the early 20th century, London had expanded so much that Greenwich was overrun with lights and humanity. The city's air and light pollution was significantly hampering the astronomers' efforts to capture and study the night sky. So the decision was made to move the whole observatory to the clearer, darker skies of Sussex. The move began in 1947, and by 1958, the Royal Greenwich Observatory was fully up and running at Hurstmonceux. The complex was constructed in the 1950s and was built to house 3 reflecting and 3 refracting telescopes in 6 green domes that you can see behind me. These domes are known as the equatorial group after the way the telescopes are mounted. But the last chapter in the story tells of the demise of the Royal Greenwich Observatory. In 1990, the Royal Greenwich Observatory closed its doors at Hurstmonceux and moved to Cambridge, essentially for financial reasons, leaving the historic telescopes behind. But 5 years later, the equatorial group came back to life as the Observatory Science Centre, and we in the public can enjoy them as we'll do today. So let's check out the telescopes here at the Observatory Science Centre. There are 6 large telescopes here on site, and 3 are available for us to visit. In Dome B, we find the 36-inch Yap reflector. The scope was built in 1932 by Grubb Parsons at a cost of about £15,000. The telescope was moved to Hurstmonceux in 1958 after 21 years of service in Greenwich, where it had been the largest working telescope. It was used primarily for stellar spectroscopy, which is the study of color spectrum of individual stars, and photometry, the analysis of the brightness of the stars. We'll hear the name Parsons later in the European Astronomy Tour series. The Parsons of the company Grubb Parsons, who built this telescope, was a descendant of the famous forebearer William Parsons, the 3rd Earl of Ross. William Parsons was responsible for the design and the construction in 1842 of the Leviathan, the 72-inch reflecting telescope at Birr Castle in Central Ireland. Look for the story of that amazing telescope in Episode 8 of KPO's European Astronomy Tour. Here in Dome E is the massive 26-inch Thomson refractor, one of the largest refracting telescopes in the world, and the 2nd largest in Great Britain. We saw the largest one at Greenwich earlier. This impressive telescope was used to take 60,000 photographs of the night sky between 1897 and 1988, capturing stars down to 19th magnitude. The instrument was constructed in 1896 by Sir Howard Grubb of Dublin at a cost of £5,000. The guide scope on top of the 26 is the famous Mers 13-inch refractor, originally mounted in the Great Equatorial Dome in Greenwich, which we saw earlier in this episode. The Mers refractor was procured and installed in 1859 by the famous Sir George Airy, the Astronomy Royal at the time. This massive telescope weighs 12 tons. And finally we come to Dome F, where we found the Congo-Schmidt telescope. This instrument is the largest and newest of the telescopes at Hurstmonceux, but it could never be used for serious observing. It was built in 1960 for an observatory in the Belgian Congo in Africa, but unfortunately, civil war broke out there before it could be installed. So it was eventually brought to Hurstmonceux, where tests showed that it was unsuitable for use for astronomy research in the Northern Hemisphere. Additionally, there were some challenges with the figure of the primary mirror itself, which essentially rendered the telescope unusable. It now serves as an impressive centerpiece to an excellent exhibit here called Domes of Discovery, which tells the story of the Royal Greenwich Observatory. Well, this has been an incredible episode where we've walked through the history of British astronomy, from its refined beginnings at the Royal Greenwich Observatory through the tumultuous transitions to Hurstmonceux. We've seen some amazing astronomical instruments this week and learned about the incredible institutions that have moved all the astronomy forward in the 18th, 19th, and 20th centuries. I also want to again thank Dr. Louise Devoy for our entertaining and informative interview yesterday about the Royal Greenwich Observatory. You can find links to additional information about Dr. Devoy in the episode notes. Speaking of which, you can view the episode notes at kpobservatory.org/EAT05, where you can find our itinerary and publication schedule for the rest of the trip. Throughout this tour, I'll be checking the site and YouTube for any comments or questions you might have, so feel free to ask away. In next week's episode, we'll visit one of my life bucket list locations, the famous Stonehenge in southern central England. We'll discuss the strange history of this prehistoric observatory and rock formation, and hopefully get some amazing photographs around sunset. Until then, happy travels and clear skies, and we'll see you next time on KPO's European Astronomy Tour.